Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
Last week, we used some real-world data to learn the basics of data wrangling and descriptive analysis. Today's tutorial is part 3 of a mini-series on data frames. I'm assuming that you've already watched parts 1 and 2. If not, please watch both of those tutorials before watching this one. The links are in the description below. Today, we'll start by getting some quick lessons on how to use the HTTP package and the data frames meta package. But we'll spend most of today using the Gadfly plotting package to understand the benefits of its tight integration with the data frames package. This should be a fun tutorial, so let's set up our programming environment now so we can get started right away. Open VS Code and maximize the terminal panel. Start the REPL by holding down the Alt key and then hitting J and O. Make a new directory called tutorial02x08 by using the make directory function. Change your present working directory to your new directory by using the change directory function. Enter the package REPL by hitting the close bracket. Activate your new directory by typing in activate *period and then hit enter. Add the following packages and versions. Type in status to confirm that all of the correct packages and versions have been added. Exit the package REPL by hitting backspace. Minimize the REPL. Create a new file by going to File, New File. Save the file as tutorial02x08.jl by going to File, Save As. Be sure to save your file to your new directory. I'm going to add a header to my file, but there's no need for you to type this in. You can access the source code for this tutorial in my GitHub repository. The link is in the description below. Let's start by adding the code to save our table as an HTML file. Go to github.com and search for julia4ta/tutorials. Click on the link to go to my repository. Click on the Series02 folder. Click on the Files folder. Click on the Save HTML.jl file. Click on the Raw button. Use Ctrl-A to select all of the text. Use Ctrl-C to copy all of the text. Go back to VS Code and click in the editor. Use Ctrl-V to paste the code into your editor. Select all of the rows and hit Shift-Enter. Last week, we learned how to convert a Wikipedia table into a CSV file. We then took that CSV file and loaded the data into a data frame. Today, we're going to learn how to download a CSV file from the internet by using the URL. In order to do this, we need to use the HTTP package. The HTTP package was created by Jacob Quinn, who is the author of the CSV package and the tables package. The HTTP package does a lot of clever things, but we're going to use it today to get some data off my GitHub repository. In the browser, hit the back arrow twice to get back to my Files folder. Select the mydf.csv file and click the Raw button. With your mouse, select the URL and copy it. Go back to VS Code and paste the URL in between quotation marks, assigning it to the variable URL1. You can download the data at this URL location by using the http.get function as the argument in the csv.file function, which can then be passed directly into the data frame constructor. Now that we've downloaded the data and stored it in memory, let's save it to disk, both as an HTML file as well as a CSV file. Open the Explorer and view both the CSV file and the HTML file. This dataset should look familiar to you because it's from the last tutorial. There's another CSV file in the Files folder on my GitHub repository. This new file contains gross domestic product data by country for 2019 collected by the United Nations. The GDP in this file represents an estimate of the market value of all of the final goods and services produced in the listed countries in 2019. Repeat the process to download this data onto your machine. In the browser, hit the back arrow twice to get back to my Files folder. Select the GDP by country UN.csv file and click the Raw button. With your mouse, select the URL and copy it. Go back to VS Code and paste the URL in between quotation marks, assigning it to the variable URL2. Open the Explorer and view both the CSV file and the HTML file for this new dataset. Easy, right? Now, let's learn a little bit more about data frames. At some point, while using data frames, you will need to match data from one data frame with another data frame. This is done using a join function. There are several different variations of the join function, but the two that we will be using are the outer join and the inner join. This joining concept comes from the world of relational databases. In order to perform these join functions, you need to have a common column in both data frames. We will be joining our new GDP data frame with our population data frame. Both data frames have a column labeled country, but there are fewer countries listed in the GDP data frame. That's because GDP data was not collected for some of the smaller countries. When joining these two data frames, there is a catch. The countries listed in both data frames must be an exact match. For example, you cannot have United States in one data frame and have US in the other data frame. Cleaning up this data is part of the data wrangling process that we learned last week. For today, I have cheated a little by providing you with a cleaned up list of countries. An outer join will create a new data frame that contains all of the countries. If there is any missing data, it will be noted in the data frame as missing. Open the Explorer and view your outer join data frame. Note all of the missing data. An inner join will also create a new data frame, but it will only contain the countries that are listed in both data frames. As a result, it will be a shorter list. Open the Explorer and view your inner join data frame. Note there is no missing data. The GDP figures are in millions of dollars, so they are quite large. Let's change them to billions of dollars to make them more manageable. Click on the df inner HTML tab to view your change. Now, let's add another column showing the GDP per capita in thousands of dollars per person. Click on the df inner HTML tab to view your new column. Now that we have our data frame set up, let's learn about the data frames meta package. The data frames meta package is a companion package to the data frames package. It contains some convenience macros for use with data frames. We're going to take a look at two of these macros today. Recall from last week's tutorial, when I wanted to find the list of countries in the Southern Asia subregion, I opened up our data frame that contained a list of all of the countries and then scrolled through the list to find the list of countries in the Southern Asia region. While that may be fine with a small dataset, with a large dataset, that might not be possible. What I should have done was to filter the data frame to find the Southern Asia subregion countries programmatically. The data frames package does not have a built-in filter function. Instead, it relies on the filter function from Julia Bayes. Let's take a look at how to filter a data frame using the filter function from Julia Bayes. Open the Explorer and click on your new file. It should contain a list of the 9 countries of the Southern Asia subregion. In order to use the filter function, we had to pair the subregion column with an anonymous function. If you're an experienced Julia user, this syntax may be familiar to you. But if you're a new user or a casual user of Julia, this syntax may not be that intuitive for you. To address this, the DataFrames meta package provides a more intuitive option for filtering your data frame with the use of the @where macro. Open the Explorer and click on your new file. It should give you the same result. This may not seem like a significant time saver, but you can easily apply multiple filters using the @where macro. Okay, so this syntax may not be as intuitive as I promised, but it does allow for multiple filters. The .or syntax allows you to use the OR condition, and the .and syntax allows you to use the AND condition. Open the Explorer, then click on your new file. This code creates a data frame showing countries in the Southern Asia subregion or the Northern America subregion, with 2019 populations of under 1 million people and with GDP per capita of greater than $10,000 per person. So that's how to use the @where macro. Now let's take a look at the @by macro. Recall from last week's tutorial that it took us multiple steps in order to create a summary data frame. First, we had to create a group data frame, and then we had to combine it, and then we had to perform a third step to add some columns with some calculations. With the @by macro from DataFrames Meta, we can accomplish the same task all in one step. Open the Explorer and click on your new data frame. This creates a new data frame that summarizes all of the data by region, including the new columns that we just added a few minutes ago. In order to create a new data frame that summarizes the data by subregion, simply copy and paste the code, replacing region with subregion, add a line to include the unique regions, and change the R to an S in the variable names. Open the Explorer and click on your new data frame. The @by macro is more than just a convenience macro. It's a real time saver. Okay, so that concludes our quick data frames tips for the week. Now, let's get to the main attraction, Gadfly. The Gadfly statistical plotting package was created by Daniel C. Jones and is written in Julia. Gadfly traces its roots back to the early days of Julia and is inspired by ggplot2 for R and the book Grammar of Graphics. Gadfly is currently being maintained by the Julia community and there have been 100 contributors to this package. Gadfly has an extensive statistical plotting catalog, and its integration with data frames makes it a natural choice for plotting if you're already using data frames. I will not be going through the entire catalog. Instead, I will take you through some examples to give you a flavor for the syntax and then refer you to the documentation if you're interested in learning more. Setting the default plot size will determine the shape of the plot that shows up in your plotting panel. Unlike other plotting packages, Gadfly uses centimeters and inches for the plot dimensions, as opposed to pixels. You might have to adjust the dimensions to fit your screen. Our first example is a bar plot. Let's plot the population data by region, but before we do, let's sort our data. Before hitting Shift-Enter, let's take a look at this syntax. My initial reaction is that it's surprisingly verbose. What's the deal with those geom dot, guide dot, scale dot, and so on? Let's take a look at the actual plot, then come back to this code. This code actually generated a really nice looking plot. Let's take another look at the code to see how Gadfly accomplished this. The first three arguments all make sense. It's just grabbing the data from the data frame. The color by region is a nice touch, so Gadfly can generate different colors for each region. The next section is interesting, with the geom dot, guide dot, and scale dot. This is part of the Gadfly package design to separate these attributes from the plotting. You use geom for the plot geometry, so rather than using a different function for different types of plots, you use the plot function but with different geometries. In this case, we're calling for a bar plot. The default orientation for a bar plot is vertical, so here we're calling for a horizontal orientation. The guides for X label, Y label, and title are all self-explanatory, but the guide for color key is different. Rather than calling it a legend, Gadfly uses color key, which is literally what it is. Scale.xContinuous is the syntax for the x-axis number format. Without specifying this, Gadfly would automatically choose the numbers format that may not be in the format that you want. Finally, you can customize the theme attributes for your plot. By default, Gadfly generates transparent plots, which I actually like. But if your programming environment is dark, like mine, it's a little difficult to see the plot against a dark background. So I selected a white background for demonstration purposes. Selecting a background color is optional. The bar spacing attribute is unique to bar plots. Leaving a space between the bars will help to distinguish it from a histogram. While it may seem verbose, the syntax is actually quite logical. You'll see for the rest of the plots, we're basically going to copy and paste this template with some minor modifications for the different plot types. Now that we understand how to generate plots in Gadfly, how do we save the output? This code saves your plot as an SVG file. Open up the Explorer and click on your SVG file to view it in VS Code. Let's generate another bar plot, but this time for the subregions. Start by sorting the subregion data frame. Now, copy and paste the plotting code from above and make some slight modifications for the subregions. This plot looks nice too. Having different colors for the different regions is very helpful. Let's save this plot by copying and pasting the same code from above and by making a slight modification to the file name. Open the Explorer and click on your new SVG file to view it. Our next plot is a scatter plot, which is called a point geometry in Gadfly. We're going to create a scatter plot showing the relationship between the population and the growth rate. But there are a few extremely large countries that are outliers, so let's remove them so we don't skew the rest of our data. Let's just keep the countries with less than 100 million people. So this is an interesting plot. We know from last week that the median population is around 5.5 million people per country, so it's not surprising to see all the points bunched up between 0 and 5. Beyond that, it looks like most of the growth is in the Africa region, followed by the Asia region. The Americas region looks like a mixed bag, but in general looks like slow growth. The Europe region looks like slow growth with several countries showing declining populations. Unfortunately, it looks like some of the smaller European countries are getting even smaller. Finally, the Oceania region is so small, it's difficult to make out those countries in this plot, but in general, it looks like the countries in this region are growing. Let's go ahead and save this plot. Open the Explorer and click on your new SVG file to view it. Next, we're going to generate a B-swarm plot. A B-swarm plot is the same as a one-dimensional scatter plot, but it uses logic to ensure that the points do not overlap. The result is a plot that looks like a swarm of bees, hence the name. The B-swarm plot is a way to visualize the distribution of your data. It's one thing to see a descriptive statistics table showing a median population of 5.5 million people, but it's another thing to see them spread out like this. Let's save our B-swarm plot. Open the Explorer and click on your new SVG file to view it. Our next plot is a box plot, sometimes called a box and whiskers plot. The box plot is a standard plot for descriptive statistics since it visualizes the minimum, the first quartile, the median, the third quartile, and the maximum. Outliers are displayed as separate points. You can copy and paste the B-swarm code from above and make some slight modifications. The solid box is the range between the first quartile and the third quartile, while the line in between is the median. The thin tails represent the minimum and the maximum, while the individual points represent the outliers. Look at how low the median is for the Americas region. Let's save this box plot by making a slight modification to the B-swarm code. Open the Explorer and click on your new SVG file to view it. Our next plot is the density plot. We've seen density plots before in prior tutorials. This next plot will show multiple density plots on the same plot. Before generating this plot, let's remove the Oceania region from our dataset. Since it's so small, it will throw off our plot. This plot shows that the Americas and Europe regions are composed of countries with smaller populations, while the Africa and Asia regions are composed of countries with larger populations. Notice that the density plot goes into negative territory. That's because it's taking the means, which are relatively small, and then applying the standard deviations, which are relatively large. Obviously, it doesn't make sense to have a negative population. Let's save this density plot by copying and modifying the previous code. Open the Explorer and click on your new SVG file to view it. Our final plot is a violin plot, so called because the output resembles the shape of a violin. The concept behind the violin plot is to combine a box plot with a density plot. In this plot, we're going to take a look at the distribution of the GDP per capita by region. Before generating the plot, let's talk about this code. For the Y label, I had to specify that the orientation should be vertical, otherwise Gadfly would print it horizontally. Also, in order to modify the Y-axis range, I added a line using the COORD.Cartesian syntax. You can think of these shapes as the individual density plots with a vertical orientation that has been mirrored, so it has a symmetrical shape. The shape of the Americas, Asia, and Oceania region look like they are somewhat normally distributed. The Africa region shows a very high concentration of low GDP per capita countries, while Europe shows a very wide distribution of GDP per capita countries, ranging from very high to very low. Let's go ahead and save this violin plot by copying and modifying the previous code. Open the Explorer and click on your new SVG file to view it. Now hit Ctrl+S to save your .jl file. That's all the plotting examples for today. Now, let's take a moment to reflect on what we just saw. Here are all of the plots from today. These are definitely presentation quality plots. I didn't spend any time going through the formatting. This is just how the plots look straight out of the box. Again, this is just a sample of the charting catalog available in Gadfly. If you're interested in learning more, I encourage you to look through their documentation. The more I use Julia, the more I'm amazed by how much free stuff there is. Like the JMP package, the Gadfly package is something that companies would be willing to pay for. And yet, here it is, available for free, so that all of us can benefit from it. And it's not like these packages are being created by large corporations. Many of these packages are being created by super smart, super talented individuals, many of whom are students. I feel like it's important to appreciate that a large part of Julia's ecosystem is being built by folks who are working voluntarily on their own free time with no hope or expectation of ever getting compensated for it. I'm not sure what inspired them to create all of these amazing things, but they inspire me to keep learning Julia. And I hope they inspire you too. Well, that's it. Congratulations if you made it this far. We started today by getting some quick lessons on how to use the HTTP package and the DataFrames meta package. We also spent a lot of time getting familiar with the Gadfly plotting package to understand the benefits of its tight integration with the DataFrames package. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julia tutorials, please be sure to subscribe and hit that bell. New tutorials are posted on Sundays/Mondays. If you have any questions, please post them in the comments below. Please feel free to share these videos since these tutorials are getting rave reviews. Just listen to what the professional reviewers are saying.
I can't say I even enjoyed one bit of it.